Hello and welcome to another session where we are continuing our discussions on Introduction to Statistics. This session will demonstrate using the statistics software SPSS to conduct an ANOVA test. So we have SPSS open over here. And I'm going to get my data file from the following book, Statistics and Data Analysis for Nursing. It has a very detailed SPSS data file from a study of 1,000 women in a certain community that they've collected all the information, various survey questions and data sets, and compiled it all that is accessible through the author's website. So that's what we're going to use in our example today. So for reference purposes, we are opening the B file. They provide 3 different sets so that you're not limited by the version of SPSS that you might have. No, I'll correct that. We're going to use the A file today. A file. I'm just going to open that one, the A file, and say yes. And there we go. So we have a bunch of variables here. Now we're going to mainly focus on the 8 variables from util cut, so that measures when or how often their utilities have been shut off, leaking in a roof, bad plumbing, and so on. So there are these 8 variables, number 25 to 32, and those are responses to a series of questions about current housing problems that the people may have experienced. So the variable house problems over here is a count of the total number of times the woman said yes to any of these 8 questions. So we're going to use this variable to create groups of the woman with different numbers of housing problems. So let's begin by running basic descriptive statistics on this variable using SPSS, and we'll click on Analyze here at the top, Descriptive Statistics, and then Frequencies, and then we're going to make this a little bit bigger. It always starts so small. We're going to look for our housing problems variable. It's over here. And then we're going to move this into the variables list by clicking on this arrow. And we're also going to click on statistics in the top right and check all the things that we want to show in the output. I'll show the mean, median, mode, just all the things, standard deviation, variance, range, minimum, maximum, skewness, kurtosis, whatever you may want. Then we'll click on continue and OK, and that will be put in our output window over here. Now I am just going to pause for a second to get a better mouse cursor so that you can track what I am doing. 1 second, I'm going to be right back. All right, we are back. Now you can see my cursor much better. We will look at our output here and answer a few questions from that, as well as our frequency table here depending on the questions that you might want. So one question could be, what is the range of this variable? And what is the minimum and maximum? So we can easily see that in the output here is a range of 8, minimum of 0, maximum of 8. That's the number of housing problems they had, from a low of 0 to a high of 8. We can also ask what's the mean, the median, the mode, and you can see that over here. For this example, let me see if I can make this a little bit bigger for us. Zoom in a little bit. No, that's not what I want. Close this. Where is my print preview? I want to print preview it. Yes. There we go. Zoom in to make it a little bit bigger. I can zoom in the other window, but here when I do a print preview, then it's a little bit bigger. So for this variable, the mean is 1.259. When I round it to 3 decimal places, 2586. Median of 1. And the mode, the most common value was 0. Let's close that. We can also look at the skewness and the kurtosis and comment on that. That tells me the symmetry. So in this case, if I zoom in here again, we see the skewness here is 1.479, and we can conclude that that is positively skewed. We can look at the frequency table here and ask, for example, what percentage of women had 0 problems? Again, let me just make that bigger by clicking on this print preview. Can I go to the next page? Next page. The next page does not want to show for me. Why not? Click on this, then print preview. Oh, that's much better. Much better. So most women had 0 problems, as we saw from the mode, and that's a percentage of 39.9%. 1 problem, 27.8%. The remaining women, all the others, add up to 32.3%, and those had 2 or more problems. So what we can do for the purposes of this example that we're discussing, we can divide the whole sample into 3 different groups. One for 0 problems, one for 1 problem exactly, and then 2 or more problems. And that's exactly what we're going to do next. So let's close this. We don't want to save it. We're back to our variable or data view, whichever one you want to look at. And now we're going to create a new variable to prepare for our ANOVA. Sometimes I might have some variables that I want to test already, but I'm going to make a nominal variable out of these housing problems by looking at 3 categories: 0 problems, 1 problem, or 2 or more problems. So it's a good demonstration how to make a new variable out of other variables as well. So I'm going to click on Transform. And then we're looking for recode into different variables, and that opens a new window. I'm going to make this a little bit bigger for us, maybe much wider, so I can see the descriptions as well as the variable name. And I'm looking for housing problems, or the housing problems group that we just looked at. Over here, number of housing problems. All right. So now I'm going to move that, and I want to make a new variable, and let's call it, what shall we call it? Housing, let's say housing problems group. Like so, it's similar, but now I'm making groups out of them. Then let's click on change. Click on change. Oh, there we go. Okay. And then at the bottom here, old and new values. I kind of have to take the values in housing problems and group them for my new variable. All right. So I don't want to go too fast here, so we can follow along, but feel free to scroll back and forth in the video if you, of course, need to. So now the old value of 0 problems will be reassigned or recoded in my new group as the first group, group number 1. And then we're going to click on add. And then I'm going to take the value of the housing problems number 1 housing problem, and we're going to put that in group 2. And then we click on add. Then for our last group, we're going to look for a range from 2 to, we know the maximum is 8, the 2 or more group, and that will be our new group number 3. And then we're going to click on add over there. So now we're making our new variable with 3 groups or categories. And then we'll continue. And we will press OK. I don't care about that. Get away from me. And you'll see here in the bottom, our new variable is a nominal variable or categorical variable, and it has been put at the bottom of the list. We can now just go and quickly check if everything adds up in this and if it was made correctly by checking the frequencies again, descriptive statistics, frequencies, and remove the housing problem one, and instead include this housing problem group variable that we just made. Let's click on OK to see that, yes, we have those same percentages cumulative here, but here is broken down as we discovered previously with the original version of the variable. Now we have our 3 groups, and they are exactly corresponding to the 0 housing problems, 1 housing problems, and 2 or more housing problems from before. All right. So of course, ANOVA is used in this kind of variable where I have categories that I'm trying to compare between each other to see if there's a difference in the means between the groups where I have more or 2 or more groups. So let's now see how we're going to use ANOVA, because we also saw, I closed it a little bit early, but if you go back and look, we have 3 groups of sort of the same size. They're fairly similar, and we can be reasonably confident that even if the variance assumption isn't quite satisfied, our statistical decision making will not be affected in using ANOVA. And because the sample is quite large, we also do not have to be too concerned about violations to the assumption that it follows a normal distribution. So now let's go and run a one-way ANOVA with our new variable as the independent group variable. So let's go and say analyze, compare means, one-way ANOVA. Let's make that bigger again. And we're looking for our group variable. That's going to go into the factor list. the different groups. And what we're going to test is the overall satisfaction rating. That is going to be SATOVRL as the variable name. And it's sometimes a little bit confusing and difficult to find these variables in the list when they are not sorted. Where is that overall satisfaction variable? And of course now, because I'm recording, I am not seeing it. Where are you? Overall satisfaction variable. Wow, I really can't see it right now. Where is it? Oh, it's over here. It's the bottom one. Of course it is. I'm looking for it in the middle when it's actually at the bottom. Okay, so that's going to go into our dependent list. And we're trying to see if the overall satisfaction depends on the housing problem numbers based on the groups, how we split it into the three groups. So now we'll click on our options here. And we'll click on descriptive and homogeneity of the variance. We want to see how is our assumption of equal variances. SPSS has those tests built in as well, and we want to see if our assumption that the variance within each group is that satisfied. So then we'll click on continue. We're also going to click here the post hoc button over there for the planned contrasts, where we're testing not if there's a difference somewhere between the groups, but testing pairs of groups that we could potentially have a difference within. And there are multiple tests, multiple ways to do that. We'll do LSD, Tukey, and the Shefay test. Click on OK there. You might want to change that alpha, but we'll stick to a 5%. And let's click on OK. And here we get a bunch of stuff. We'll just start from the top. And we can go through some questions and where to find all these things.
Welcome to MathCats, where we aim to better understand mathematics. Join us weekly for discussions on elementary, high school, through to university math. You can request the next topic by leaving a comment on our YouTube channel or by emailing us at mathcats314@gmail.com. And as always, remember to like and subscribe. Thank you.
So let's go slowly through this. So first of all, what is the mean levels of satisfaction in these three groups? I didn't go into exactly the scale of these satisfaction numbers and the ratings, but that's not quite relevant for us right now. We have our three groups over here. Let me do the print preview so I can zoom in a little bit on this, but I'll have to do it individually, it seems. So we have our three groups, and here are the mean satisfaction ratings. You'll see they're fairly close to each other, but is there a significant difference between these? That's why we need a more logically structured procedure to identify, are they still close enough? Or are these differences between them significant to suggest that there's a difference between these groups in how satisfied the people are? So we can read things directly from the table and see the means. Something on my mouse that is annoying me. Then we can... So we see that the group 1, remember, was the group with 0 housing problems, and they have a higher satisfaction score than group 2, the group with 1 housing problem, which is still higher than group 3, the group with 2 or more housing problems. So it does suggest that there might be evidence that the fewer housing problems correspond to a higher satisfaction rating. But we need to test this more accurately. So let's close that for a second. Next up is SPSS testing, whether we can assume that the variances are equal. And so Levine's test tests the null hypothesis, are the variances equal? And we see here the p-value of 0.122. So if we test that against the standard 5%, against 0.05, we will see that that little hypothesis test to test the variance equality, it is not statistically significant, which means that that variance equality assumption cannot be rejected. So there's no evidence to say, or there's not strong enough evidence to say that we can't continue with that assumption. All right. Now we can look at the F statistic that is being calculated. Remember, this is a different distribution coming from the F distribution to test the equality of the means between these groups. And they're, of course, samples of a larger population. So we see here the degrees of freedom as well. And the F statistic over here, let's maybe zoom in on this guy. A little bit bigger. F statistic there, 61.674 with a p-value of less than 0.001. If it's all zeros, 3 zeros, it means there is a p-value, but it is smaller than the smallest 3 decimal number. So we see here a super small p-value, which gives us an indication to the strength of our evidence that if we assume the null hypothesis is true and the groups are actually the same, then we would get a score this large in fewer than 1 in 1,000 samples, just due to random fluctuations. Some scores, some samples like this could exist, but they are extremely, extremely rare. And if we test this against an alpha of 5%, 0.05, or even 1%, we are definitely rejecting the null hypothesis that all these groups, all these populations are the same, and that the means are the same. Alrighty. So we'll definitely reject the null hypothesis in our ANOVA test and conclude that there is a difference in the means, the mean satisfaction rating, somewhere between these groups. But then, of course, we don't know if we look at this again, is the difference coming from group 1 versus group 2 versus group 3, 1 versus 3, all of them? The only thing that ANOVA says is that there is a significant difference. So the multiple comparisons can tell us where is this difference more specifically. And that's where there are multiple tests, unfortunately, just to confuse us further, that can be done. So SPSS, when we checked all those, does all of them, and we can see, do they agree? Is there some disagreement? And if they all agree, then we're even more confident in our conclusions. So according to the Tukey test, for example, all the group means were significantly different. So it's testing group 1 versus 2 and seeing, yes, there is a significant difference. Group 1 versus 3, and there's all the combinations of pairs from these 3 groups. that I can test individually for differences just between them to better understand why is ANOVA telling me there's a difference. There's somewhere, but where exactly? So in other words, women with no housing problems, that's group 1, were significantly more satisfied with their overall material well-being than women with one problem, group 2, and those with 2 or more problems. So there is, in this case, significant difference between when I compare any pair of groups, 2 at a time. And all the tests agree as well with that information. So now let's wrap things up by just quickly talking about effect size. I'm going to close this. I don't need to save it. And we're going to do it again, sort of, but this time we're going to go analyze, compare means, and then select means. I'm going to make this bigger again to find our variable, which would be at the very bottom. Put that in our dependent list. And then we're going to click on options. And at the bottom here, and check ANOVA table and eta, which is eta square is our effect size. Then we'll click on OK. And we have a little table here. This is not the table I am looking for. Did I not do that right? Let's do it again. Let's do it again. Analyze, compare means. Oh, I didn't do the variables right? Let's get rid of that one. We need the satisfaction variable. Satisfaction rating. So our independent list is our groups. Our satisfaction rating variable is our variable that depends on the groups, or that's what we're testing at least. Now we'll go to options, check ANOVA here, and then say OK. Oh, that's much better. And at the bottom here, we'll just print preview that so we can zoom in and zoom in some more. And we can see here the effect size, eta squared, is 0.117. So that means nearly 12% of the variability in the women's satisfaction ratings can be accounted for by the housing problems they experienced. The remaining variability could reflect, for example, how happy they were about other aspects in their standard of living, how much space they had. It could be all kinds of other variables that affect their overall satisfaction as well. The effect size just tells me how much is accounted for by my housing problem variable specifically. All right, so that runs us through using SPSS for some basic ANOVA tests. Let me know if you have any comments or questions on this. And if you feel anything was a little fast, remember you can slow down the video, go back, watch it again, and better understand the steps we went through and what we clicked and where. All right, until next time.